Good evening, everyone, again. Sorry for the technical difficulties, but it seems like things are working now. I'm just going to start from the beginning and reintroduce myself. My name is Hannah Griffiths. I am the Citizen Science and Education Coordinator for Stream Team and Master Naturalist, and I am based out of Missouri Department of Conservation. Um, we're going to have a few, or at least I think two different times that we're going to pause for questions, but feel free to enter your questions in the chat as we're going. And since we're no longer in webinar mode, I'm going to ask that everybody keeps their mics muted, just at least for now, to keep the distractions down during the presentation. And we're going to go ahead and get started. So tonight we're going to be talking about the Clean Webinar Act, and we have Garrett Franson and Tabitha Gatz Hendricks here from the Department of Natural Resources. They are Stream Team volunteer coordinators, and they're going to be presenting tonight. So I'll turn it over to them.
Thank you, Hannah. I'll turn my camera on for just this little getting started here, but glad to see everybody here again. Hopefully most people that were in the previous room are able to make it over. So again, I'm Garrett Franson. I work with the Stream Team program and Missouri Department of Natural Resources. Some of us had talked a little bit ago about getting some educational content out for people that have been with the program and other volunteer programs for a bit. And I thought it'd be a good idea to start talking about some water because we do a lot of work with water. And the Clean Water Act is a piece of legislation that kind of guides a lot of what Tabitha and I do within the Department of Natural Resources. And as a result of that, has impacts on what we do with the Stream Team program and what volunteers have going on within the Stream Team program as well. So we're going to provide just a little bit of an overview on the Clean Water Act, and I want to preface it right away. Neither of us are experts on the Clean Water Act. This is an enormous piece of legislation. I don't do policy. I don't do law. I've very tangentially worked in it, and that's about it. So we've both had to do a good bit of research to learn enough to share back with you. So forgive any slight simplifications or miscommunications on some very detailed aspects of this legislation, but we're going to try to give you guys an overview on what it is and what it does and how we're connected to it. So turn off my camera for some bandwidth help, hopefully, and we'll get started. If I remember to share my screen first, that would help. Okay, slides are back. Hopefully everyone can see those, and I'll see some chats pop up if we don't. So we're going to break this into two little chunks. In the first part, I'm going to give us a little introduction to the Clean Water Act, what got us there in the first place, what its big picture goals and structure is, and then get into the weeds a little bit on a few of the sections. Clean Water Act is a very large piece of legislation, and we're not going to cover all of it, but we're going to try to hit some of the most important aspects, and especially the aspects that most directly relate to what we do within DNR and what directly matters for Stream Team and other water quality efforts. So after we take some questions in the middle, if there are any at that point, we'll hand it over and Tabitha will take on part two, where we dive into even more weeds of even more sections of the Clean Water Act. But before we actually talk about what the Clean Water Act is, I think we need to back up and start talking about how we got to having the Clean Water Act in the first place, or what helped push the creation of this legislation. So there are a ton of reasons that I really could get into, and maybe we'll do that in some future presentation. But I just chose a few that I find meaningful and really do seem to have had a pretty big impact on getting not just this, but many other large pieces of environmental legislation passed. Clean Water Act is far from alone. It is a pretty monumental one, but it does not do the sole lifting for keeping the environment healthy. One of the biggest pieces that really changed the landscape of this was the passing of the Migratory Bird Act, I think back in 1918. One of the very first pieces of big environmental legislation protecting almost every single bird species in the US. We were overhunting them, we were pushing them to extinction in a lot of cases. And that helped just say, we can do things for the environment. Rachel Carson published Silent Spring back in the mid-century as a result of declining bird populations. That's two bird things, just by coincidence, from our overuse of pesticides, insecticides, especially DDT. And so all the songbirds in spring were no longer there to sing, and so the spring was silent. Jumping over to the right, we have an image of the moon and the Earth in the distance from the Apollo missions back in the 1960s and 70s. And this one also, in its own way, really helped change the mindsets of humanity as a whole. Never before had we seen the entire planet through human eyes at one time.
This meeting is being transcribed and summarized
At one time. Just a quick reminder, if you guys have your mics on, we'd ask that you please turn them off. We're getting some strong background noise.
Make sure your mic.
Okay, I'm just gonna hope to keep going. So we were able to see the moon from human eyes, the Earth from human eyes, from a great distance away, and see just how small it is and how thin our atmosphere protecting us from space is, and just the vibrancy of this living planet. And it's just one of those things. There's a before and after that really helped change the way we see ourselves and the planet we live on. And in the center, if you've ever been to a Stream Team presentation before or just heard us talking about water history, you've surely heard of the Cuyahoga River burning. You've probably seen this photo before if you are in the know at all, and this is actually not a photo of the Cuyahoga River burning in the most monumental of its many, many burnings. This photo is actually from the early 50s, but the landmark event, the single burning of this river that really made a difference was, I believe, in 1969. And the mayor of Cleveland, Carl Stokes here, it's his initiative to really make this a national focal point that brought the Cuyahoga River burning and other rivers burning to widespread attention. He was committed to making a rightfully big deal out of a river set afire, and it finally stuck with a broader audience, and people were just kind of saying, this is enough. We can't have, if nothing else, rivers on fire. So these all helped prime people to say, there are things in the environments that we would like to see changed. The environment is not as healthy as we'd like, and we've done it before. We can do it again. Let's pass some laws and try to make some improvements here. One of those biggest pushes was the Federal Water Pollution Control Act of 1948. This is a precursor to the Clean Water Act. Indeed, the Clean Water Act came out of many, many overhauls and modifications to this act of 1948. And it didn't come just because of the things I mentioned. It came actually before some of them, but it did follow multiple river burnings. And just to be clear, the rivers themselves were not on fire. They were just so loaded with pollutants that all of those pollutants in the water were able to be set on fire despite being surrounded by water. Those pollutants wouldn't only catch on fire, they would kill wildlife. You can see in this image a massive fish kill from an over-pollution event. And in its own way, it kind of makes sense that rivers would have been so dirty back before we, in a way, knew better, because rivers flow. If you see a river, whatever's in that river is going downstream away from you. So if you want to keep things clean where you live, put your trash into the river, and it's somebody else's problem further away. But of course, that's not the way to do it, and we have learned much better since then. And we decided, we can't just keep doing this without any sort of guidelines. So we passed the Federal Water Pollution Control Act, we overhauled it, and out of those overhauls, we got the Clean Water Act. It kind of emerged in the 1970s. It was amended pretty heavily again in the 1980s, and it's not still a finished product. This is a massive piece of legislation that is still fairly dynamic. It goes through amendments and changes on a decently regular basis that have pretty widespread implications that we'll get into just a little bit here. So that's just kind of setting the stage. It's one of many large pieces of environmental legislation, but it's perhaps the biggest one of our direct relevance with water quality. So big picture of the Clean Water Act is that it's supplying structure for how we can regulate various aspects of water quality. Regulations are basically just the laws. They tell us what we can do, what we can't do, and when they let us do things, tell us how much of something we can do, and what happens if you don't do that, or if you're not allowed to. It tells you exactly some conditions that you can't meet or exceed. And the Clean Water Act provides the structure for regulations on discharges of pollutants into waters of the United States. And it also deals with surface water quality standards and point sources. That's a bunch of jargon. I'm just going to leave it at that for right now because we are going to touch on pretty much every single one of those terms here coming up. But it has, in its own way, a pretty narrow scope, right? There are 4 bullet points there that tell us what it's about. But though it's narrow in that way, it covers a lot. Just talking about what waters of the United States are is a pretty big thing that we could spend a whole lot of time on. Surface water quality standards, there's an entire other webinar right there. So it's narrow in its own way, but that narrow scope still touches a huge amount of detail. So what the Clean Water Act ultimately aims to do is, and this is pulling pretty much straight from the document itself, restore and maintain the chemical, physical, and biological integrity of the nation's waters. If you've been monitoring with the Volunteer Water Quality Program, Water Quality Monitoring Program, you're familiar with doing chemical monitoring. That's our pH, that's our conductivity, our DO, our nitrates. You've done physical sampling, that's examining the rocks at the bottom of the stream, that's measuring flow. And you've monitored the biological aspects of the stream, that's looking at the algae, that's looking at the macroinvertebrates. The Clean Water Act says, let's get these aspects of our waters back to healthy status and keep them there. Pretty simple in concept. Also pretty simple in concept is saying, by 1985, remembering that this was kind of passed in the 1970s, by 1985, let's just not put any more pollutants into the water. Simple. Well, I mean, you can go to a lot of different waters out there and you'll see that it's not quite that simple. It was very ambitious, and I'm sure the authors meant well. We are not there, and given what we're going to get into a little bit, I'm not sure we'll ever technically be all the way there. But in the meantime, they also aimed to have water quality that is both fishable and swimmable, which are probably a couple of terms you've heard discussed with water as well, where if you want to eat a fish out of a stream, well, you have to have fish there in the first place. And not only do the fish have to be healthy enough to live there, they have to be healthy enough for you to eat. You don't want a fish that's full of heavy metals or other pollutants entering your body afterward. If you want to swim in a stream or just splash around, you need to be able to do that without yourself getting sick or injured otherwise. So, if we're not going to stop polluting, let's at least have waters that are fishable and swimmable. That seems a little bit more achievable, at least. All of this cleanup, though, especially if we're going to have zero discharge of pollutants in about a decade's time, that takes a lot of work. We have to have infrastructure in place that'll allow us to not only perhaps manufacture what we want and otherwise conduct industry as we want without polluting as much, but we also need to be able to clean up what we've already put out into the environment in the first place. That takes a lot of work. That takes a lot of money. And the federal government decided, that's important enough. And part of the Clean Water Act is to help out with funding and other resources to construct publicly owned waste treatment facilities. So these are treatment plants that take what's coming in, clean it up, and put it back out. And they're typically owned by cities or other municipal groups. So before we get too far into things, this is one of those terms I mentioned earlier, Waters of the United States, or WOTUS. We should spend a second on this. It's one of these interesting cases where it is such a critical component of what the Clean Water Act can do. It says it's relevant to waters of the United States, but the Clean Water Act itself doesn't actually define WOTUS. That comes from the Environmental Protection Agency, or EPA. And having the term, this critical term, defined kind of outside of the legislation can make for a little bit of some tricky maneuvering sometimes, but there are a lot of details on this slide and the next one, and I'm not going to get into those. Again, this could be an entire webinar unto itself, but WOTUS is, in a very simple way, almost any water you can imagine within the confines of the country, unless it's a water that is very clearly somebody's private property. Say they dug a pond in their backyard, it is strictly within their own property boundaries. It's probably WOTUS, or it has a very good chance of being WOTUS. So these are some examples posted up on the slides. I saw a question in the chat and Hannah's answering. You will have these slides, so you can review these examples a little bit later. The one I do want to say is the italicized one at the bottom. Wetlands. Wetlands had protections in a certain sense under WOTUS, and the Clean Water Act, being a living document, responds to what the definition of WOTUS is. And more recently, a Supreme Court case has modified our interpretation of what waters count as WOTUS or not. So whatever happens to WOTUS affects the Clean Water Act, and whatever happens to the Clean Water Act affects how much water quality we're able to affect via regulations. So there are a lot of consequential pieces here that all fit together, and just moving one can affect the others. One more little thing before we continue. I said at the beginning, of course, we work with DNR, Tab and I do, and we also work with the Stream Team program. It would behoove us, I guess, to say just a little bit about us as well and where we more professionally fit into things. So the Department of Natural Resources formed in 1974, just a little bit after the EPA was formed, and DNR came out of basically just a shuffling around of state groups. Anybody that basically worked with land, air, water, energy, and cultural resources got consolidated into the Department of Natural Resources. We are, of course, in the water section, but there are a lot of other components that still work together to try to improve our environmental landscape and cultural landscape here. Missouri Stream Team program, I'm hopeful that most of you know a little bit about the background, but Stream Team formed in 1989. There was a group of fly fishers down on the Ruby Day River that wanted to ensure they had healthy water that the fish they were after could survive in and thrive in, and provide recreational opportunities for them. And so they decided to take it into their own hands and try to make a difference on the local scale on their own. That quickly blew up in a very positive way. And not too long after, the realization was made that, more than what just the Stream Team program can do, which is a lot, there should be a monitoring aspect as well. And that's something I'll touch on just a little bit later. But the VWQM program that most, if not all of you are part of, came after that and has been a pretty important part of Stream Team ever since. So what we do, not only with DNR, but also with Stream Team, if you guys remember from your workshop days, us talking about water chemistry especially, centers around water quality standards. These come out of sections 303 and 304 in the Clean Water Act, and they can be broken into three major components. The first one is designated uses, or what we intend the water to be used for. Criteria, so basically how much of certain things should or shouldn't be in the water, or what should the water be like ultimately. And anti-degradation, so it's not enough just to get the water healthy again. Once it's healthy, we need to ensure it stays healthy. It can't backslide and degrade. We want to have an anti-degradation policy here. So some examples of these components of water quality standards include, for designated uses, say you want your stream to be able to support life. Streams are more than just water. They include the physical environment, they include the biological components. And so we want to make sure that streams, lakes, they can support the organisms that are supposed to live there. We get a lot of our drinking water from streams and lakes and groundwater, and we need to make sure that those waters are healthy enough for us to, with some treatment, drink and not get sick from. Criteria, these are numbers and their descriptions. So if you remember from those workshop days, pH, we should have a pH in Missouri's waters between 6.5 and 9.0. There are some natural exceptions, but generally speaking, this is where we should be. And if it's outside of those values, we have an issue. And very loosely speaking, we don't want our streams, our lakes to be weird. We don't want them gunky. There shouldn't be scum on the top or weird sludgy deposits on the bottom. If they're just kind of obviously not natural, not quite right, we don't want that. And that's one of those more narrative or qualitative criteria. And for that anti-degradation, again, once we have a water that's actually meeting our criteria, it's healthy enough per our numbers and our qualitative criteria, we shouldn't be able to put things back into the water that would make it get worse than those criteria allow for. So anything that would say raise the pH above 9, you just can't do that. You already have the stream healthy enough in that regard, and you shouldn't be allowed to make it worse again. So water quality standards set those numbers and set those other descriptions for how waters should be. And this is where it gets a little bit tricky because, the Clean Water Act said we should have no discharge of pollutants by 1985, but we still do pollute our waters. The standards say what the water should be, and as long as we're not exceeding the standards, in a way, we're allowed to pollute, and that's what a lot of what DNR has to deal with is about. And we'll touch on kind of what that means first, and then what DNR does about it afterward. So there are two primary sources of pollution that we're going to talk about here. One is point source, and the other, spoiler, is non-point source. Point sources, this is kind of a straightforward concept. This is riddled with a few big exceptions, but it's basically anything that's coming out of a pipe. If there's a pipe and there's water coming out of it, that's a point source. The big exception I want to mention is up in agricultural areas, north in the states and elsewhere in the Midwest, tile drainages under agricultural fields. Those are pipes. They drain water out of the fields. They don't count as point sources. I'm not going to get into why. I'm not sure I understand myself well enough, but there are some exceptions where clearly that's a pipe, and yet clearly that's not a point source. But point sources, they're discharging. They're going clearly from point A to point B and pumping water out along the way. And that water usually has at least a tiny amount of some sort of pollutant. And that pollutant is the point source pollution. The water is a convenient way for it to get around. These point source pollutions or pollutants are pretty easily regulated. If you look at these pictures here, those are pipes. There's an open end. One of them has water coming out, the other doesn't in the moment, but they're pipes. If in theory you don't like what's coming out of that pipe, this is a dramatic oversimplification that I would not recommend anybody doing in practice, just plug the pipe. You know where it's coming from. If it's bad stuff coming out, just cover the pipe. That's in a way what DNR can do in a more formal process is say, we know what's coming out of the pipe. We know where the pipe is. We're going to shut the pipe. Simple as. In reality, it's not that simple. And in reality, most of our problems are coming from non-point source pollution instead of point source pollution because it's so easy to shut down those pipes in an official regulatory way. Non-point source pollution is essentially anything that's not point source pollution, which sounds like a cheap answer. In a way it is. It's a very wide umbrella term. It includes those tile drainage, as I mentioned earlier, but most of what we're talking about here with non-point source pollution is runoff. So when it rains or you have water spilling in other ways, it runs across the surface of the earth, whether that be a natural landscape, be it an agricultural field, be it an urban environment with all these impervious paved surfaces. And as that water runs across those surfaces, it picks up pollutants from the landscape. That can be car tire dust, that could be your lawn fertilizer, that could be pesticides sprayed on an agricultural field, that could be cow or bison poo, that could be a number of things. A little bit more subtly, though, it also includes precipitation itself. So if you think back to the acid rain days, there's pollution within the rain itself that's making it acidic. That's non-point source pollution. It's coming from kind of everywhere at once, in a way. Stuff that falls out of the sky. We have mercury coming from a lot of dispersed sources that gets into the atmosphere and just rains down little by little everywhere. That's non-point source pollution. It's not coming from a single place. You can say, well, that's clearly coming from Farmer Bob's field. Yes, that's a single place in a way, but we're also talking about the entirety of the field moving at once. It's a little bit harder to regulate. It's a little bit harder to say, don't rain here and don't let the water that rains down anyway go anywhere. It's just a trickier thing to manage, and that contributes to it being a source of a lot of pollution that we still have in the state today. So Clean Water Act said no pollution by 1985. We're saying, and I have photos of, pipes that are clearly pumping out water, and that water, take my word for it, has at least some slight levels of some pollution inside. Why is that still happening? I'm going to try to say this well, but basically the Clean Water Act and federal and state authorities allow for pollution in very controlled ways. A lot of what people do naturally comes with a consequence of pollution, be it just a little bit of waste here or there or large scale discharges. What DNR does, and in some cases the federal government still, is issue permits. This is one of the most important things that the Natural Resources Department does, is say, you're allowed to pollute in a very specific sort of way. We issue what are called NPDES permits, or National Pollutant Discharge Elimination System permits. And they are about point sources, so coming out of a pipe, going into waters of the United States. They include a lot of different things, but in short, they cover water coming out of pipes into almost any water body you can think of. However, they are very limited in scope. They say you are only allowed to pollute with certain amounts of certain things for just a few years. You have to tell us what you're doing, you have to give us data, and you have to let us come check on you. It's a very controlled thing. In theory, permits are supposed to comply with water quality standards and say, you are not allowed to make the water get outside of water quality standards. And you're not allowed to get a water that is already healthy back to an unhealthy status. And for the most part, this works. Most of our point source discharges are not exceeding water quality standards, and we have a pretty formal process within the department to address those cases where they are. Permits, due to the tricky nature of non-point source pollution, don't really apply in the same way in those cases. Again, think about Farmer Bob's field. You can't really stop the rain from coming down onto his field and washing things away. There are other things that can be done about that, and we'll touch on that just a little bit later too, but non-point source pollution is a little bit trickier to get permits that fully address the issue written for. So these, in our case at least, are restricted a little bit more to point sources. So again, where DNR comes in is largely to just write these in the first place, and we write them for a lot of different types of dischargers. But we also get to go and do inspections and monitoring about the facilities. So we have a few different teams that do this. We have people that'll go to the facilities themselves and speak with the people that work there and check out the systems in place and a few other things that I'm not directly familiar with, because my role, you can see a couple of my colleagues here, we go out and collect water that's coming out of the facility. So after it's gone through all the treatment, they've put it through the process, we see just how clean that water is, and also, is it having an effect on the stream? We want to make sure that we are checking every single part of this treatment process with multiple teams. So DNR writes the permits, but DNR also follows up on what we permitted in the first place. DNR also doesn't, however, have the final say on permitting. We have to abide by decisions made by this board called the Clean Water Commission. They meet every so often and deal with a lot of formal matters in a pretty procedural way. And some of those things they discuss are whether a permit that DNR wrote should actually be struck and not valid, or say DNR said you don't meet the conditions to have this permit, and the Clean Water Commission says actually write that permit anyway, and so we will. For the most part, that doesn't happen. DNR is full of people that are very, very good at writing permits. This is their job. They are experts in the field. But the Clean Water Commission still does have this authority and occasionally will intervene in some ways. And this is true for a lot of what DNR does. So one of the last things I want to talk about here, also coming from Section 402, like permitting, is land disturbance. And you might be thinking, I signed up for a webinar on the Clean Water Act. We're talking about land here, and that is so true. We talk about land disturbance within the context of water quality because we see what happens to the landscape affect what happens in the water. Land disturbance includes a lot of different things, and there's a much more technical definition that you can go find, but basically anything that's affecting the surface of the landscape and a little bit down into the land itself over a sizable area. And that size can be anywhere from an acre minimum or down to 3,000 square feet, depending on how sensitive the environment is. Say there's a bunch of sinkholes in the area going right into caves or groundwater. You have to be a little bit more careful. But basically anything that's disturbing the upper surface and a little bit further down of the landscape requires a stormwater pollution prevention plan. This is a way of addressing potential runoff and sediment issues. And it aims to reduce the amount of soil that's exposed to disturbance in the first place, how much can erode off into a surrounding water body, and then how much sediments, the pollutants that we actually care about here, can enter a water, regardless of the previous two factors. So it's really because of that sediment that we care so much about land disturbance in a water context. Not only is sediment one of the primary pollutants of waters in the states, in the country, in the world. If you think about, again, our workshops, we talk about little fine particles clogging up the larger rocks at the bottom and cutting off a lot of habitat and structure to streamscapes. But also sediment likes to have things bound up against it. So anything that the sediment is tumbling through or anything that's applied to the landscape can get attached to the little bits of soil, to the little bits of clay and sand and rock. And when the sediment goes into the stream or lake, so too do those pollutants. So if we look at this big grassy field in the photo here, maybe some of that has been fertilized to get so green, or maybe that looks like row cropping in the background and other things have been sprayed on that surface. That stuff will partly run off and hopefully mostly just soak into the ground, but then it's attached to the sediment if it's not taken up by plants. If that sediment goes, so does the pollution. So we have a few strategies that can hopefully reduce, if not eliminate, the consequences of land disturbance toward surrounding water bodies. You've probably seen sedimentation fences or silt fences or these contour baggies that are supposed to help reduce runoff. So that's why we care about it. It is a non-point source pollution type, which is just, again, a large contributor of a lot of the pollutants we still see. It's a little bit harder to address than clogging up a pipe. Okay, so I'm wrapping up here. We've talked about a good handful of things already, and I saw some people putting some questions in there, so keep them coming if you have them. But I also wanted to talk a little bit about volunteers. Um, I have a couple slides here, and I'm going to go on a little preamble before I go on the actual ramble of it. But I want to say first that what you guys do is just really, really important to our environment, both the water and the land itself, and all the organisms that live among it. Um, Anything I say here uh, is tied to anything else I might say. So well, that didn't come out well. What you guys do and what we're going to discuss here as things you can do or get involved with matters not just for what you do directly, but because it ties to so many other aspects as well. If you go and pick up some litter on your sidewalk, that's helping water quality in an indirect way. If you clean trash out of a stream, that helps land quality in an indirect way. And there are things that you can do other than just picking up trash. But I just want to make that point clear too, that just participating in any sort of um, action that aims to improve the environment does more than just the action itself, because so much of what we do is connected to everything else we do. One of the most important things we can do, though, is monitoring. So that'd be our volunteer water quality monitoring program. Um, we can't get a good idea of how well any of our actions are doing if we don't have data to back it up. So monitoring is a way of getting that data and saying either what I'm doing is great and I see a clear difference in my environmental quality here, or what I'm doing maybe isn't that effective. And instead of doing this, I should switch methods and see if that's a little bit more effective for what I want to achieve. Um, so I'm a little bit biased because I do monitoring on my other part of my role, DNR, but also very heavily biased for the VWQM program. There are a lot of things, and again, I'll have some examples here on the next slide that you can do, but if nothing else, I really want to emphasize you guys taking down this phone number here. DNR has our Environmental Emergency Response Team. It's basically our 911 for nature. And this is the phone number you can call 24/7 any day of the year. We have people on the lines. We have people ready to go anywhere in the state if there is an environmental emergency. And you might say, well, I don't really want to call 911 if I'm not sure it's actually an emergency. And that's, a reasonable hesitation, but I want to dispel it here. If you think something is off, if you know something is obviously wrong, or you're just not totally sure, but something just raises a flag, just call the number. People will answer and people will listen to what you have to say and decide for the state if that's an important enough thing to send the emergency crew out to, or what is the appropriate response. So I have this contact in my phone. I go out across the state on personal trips and on work trips. And if I see something that's just obviously not right, I'll just call it in. They can decide if that was something they needed to go and send themselves out for immediately, or maybe it can wait for the next day, or maybe they're just not the right people anyway. That's just a really good number to have on hand. So finally, just a few things that you guys can get involved with. Some of them are a lot more hands-on. So again, that picking up litter example, we have storm drain stencils that you can use to spray or chalk onto storm drains and say, hey, this water goes somewhere. It goes to where the fish live. This is a stream that runs behind my home, and I don't want to see your trash running into it. Just be mindful. You can also incorporate best management practices into your life. So if you love having that green grassy lawn, just don't fertilize it before it rains. You want the fertilizer to do its job for the lawn and not run into the stream instead with that the rain washing it in. If you live in a more urban environment, you can also work to build some bioswales. These help slow down that non-point source contributing runoff in a city and try to slow it down, soak it in, have some nature, have some plants, have some bugs, come back and be able to live there. If hands-on things aren't really your type, you can also be more of an advocate. You can have your own presentation to your friends or family and just say, hey, this is what water quality is, or this is what I'm passionate about, and this is what I do to help, and this is what you can do to help. teaching is just a great way of not only getting yourself more informed. Again, I didn't know much about this in the Clean Water Act before this presentation, but it also teaches others and gets more people informed. Government meetings are also a great way of being involved. DNR and MDC, for that record, count as government, but so does your city council, so does your state representatives, so do your state senators. You can write to them, you can show up in public meetings, and you can say, hey, this is something I care about, and I would like to see the government do something about it. Or you want to pass this law, and I think there should be some changes to it. We have a branch of or a sister group, basically a partner group called Stream Teams United that does a lot of advocacy work, and they are a great one to get involved with if you are more interested in that sort of pursuit. Stream Team also just has more than water quality. A lot of the activities we get involved with are, of course, directly related to water quality. We are the Stream Team program after all, but you can do things like plant trees that indirectly, in some ways also just directly improves water quality. And this one's a little bit more niche, but if you happen to work for an MS4 in a much more urban environment, there are certain requirements you'll have to meet your permits, and you can meet some of those requirements through the Stream Team program. We've done some workshops before where people that work in MS4s have come out and learned what's going on in the streams that they work around, and had a really good time and took that information back to their job and hopefully are making some improvements around. So just a lot of options here. And I hope you guys have learned something from this first portion and just have your brains going a little bit on what you could do. I'm going to stop sharing right now. I saw a couple of questions coming in, and I know we were thinking about taking some questions in the middle before handing off to Tabitha. So take a look here in the chat really quick. Okay, right at the bottom, perfect. Saw the one about the slides already addressed. So what plan is in place to monitor the meat slaughtering plant that is going to be operating in Warren County? I don't know about that plan specifically. I can't say terribly much about it, but generally speaking, any plant that is approved and thus permitted has to pass certain regulations, basically. They have to be reporting their own data to DNR to verify what we're doing is within the bounds of our permit. And they have to let us, if we choose to, come out and take our own data and say, you are doing what we say you can do, and all looks good here. So that's about all I can say. DNR is tied a little bit in that, you know, even if we personally might have some qualms with the necessity or quality of a facility that is going to be permitted, as long as the facility is able to meet requirements passed by Missouri State Legislature, we have to permit them. DNR doesn't get to just say, we don't like you, we won't permit you. If they're doing things legally and what the law says is acceptable is met, DNR has to permit them. So we have some authority, again, collecting and receiving data, but we can't do just anything we want about those sorts of things. Laura, I read your comments as a response as another question, but that seems to be a response. So yeah, we have limited authority here, but we do have some. And Gail asked a question about what an MS4 was, and I really hoped nobody was going to ask that question. But I am slightly prepared. I had a web page pulled up as I was reviewing beforehand. But an MS4, it's a municipal separate storm sewer system. Those are the 4 S's. And loosely and probably incorrectly speaking, this is basically a system that passes rainwater, stormwater through itself and discharges it. This is not a sewer combination system, and is really, again, just focused on stormwater. So it's not really cleaning the water so much as just helping move the stormwater around. But MS4 is just municipal, and then SSSS. We have a page on DNR's website about that if you want to read more. That would probably do better than my little quick summary of it. But if you guys have more questions, feel free to put them in the chat, but I'm going to hand it over to Tab at this point.
Perfect. Can you all hear me? Or Garrett, can you hear me?
You are coming through clear.
Okay, perfect. All right, can you see the presentation in presenter mode? Trying to figure out how to move the slide forward. All right, so that was a lovely introduction and beginning of what is the Clean Water Act. And as Garrett mentioned and as Hannah mentioned, my name is Tabitha Gatz Hendricks. Garrett and I work really closely together with the Stream Team Volunteer Water Quality Monitoring Program. And I'm going to finish us out for the rest of the evening with some more sections of the Clean Water Act. So we'll start with sections 404 and 401. So section 404 are permits that are issued by the United States Army Corps of Engineers, or USACE. And the Army Corps issues these permits federally, and they basically regulate the discharge of dredged or fill material into or out of waters of the United States. And I know Garrett touched on WOTUS earlier in the presentation, and entities who are interested in applying for or have some of these permits, if they're not sure that the water body in question is a water of the United States, then the Army Corps of Engineers, part of their job is to help folks determine if it really is a water of the United States. So it is can be kind of a nebulous thing, and so they understand that and will help people discern what is a water of the United States. Generally, 404 permits are less stringent than 401 permits that are issued by Missouri, which I'll get to in just a second. And they focus on sort of the broader surrounding ecosystem of the water of the United States that the permit is referring to. Here are some examples of 404 permitted activities. So this could be things like building a road or a bridge, levees, dams, highways, airports, things like that. The links in this on this slide will take you to the Army Corps of Engineers St. Louis district specifically, where I got these images from, and you can actually go in and it will describe the projects here and sort of what they did. So if you're interested, you can follow those links once we send out the slides. So it's a little bit broader than just what some people might conventionally think of as, dredging water from, big rivers. It can be really a lot of different types of construction happening around waters of the United States. But like many permits, there are also exemptions. So here's just a few of the exemptions for 404 permits, and a lot of it has to do with things that are already happening. So normal farming practices or maintenance of things that were already built that already had a permit attached to them, or smaller projects like construction of stock ponds and farm roads, things like that. So many permits have exemptions. And here's just a few for the 404 permit. So as I mentioned earlier, Missouri issues permits in conjunction with 404 permits, and these are called 401 permits. So essentially, these permits just make sure that any Missouri specific laws surrounding this construction projects are followed. So these could be, specific guidelines or best management practices, maybe like silt fencing or, keeping material where it should be rather than going somewhere where it shouldn't be, and anything that will essentially make sure that the nearby water body maintains water quality standards, like what Garrett talked about earlier. And these permits can also include mitigation efforts. So if you destroy a section of a stream to build a dam or a bridge, then you might have to sort of do some restoration, some mitigation efforts to ensure that, that section of stream can still maintain what it should be maintaining. So that's sort of the Missouri specific permit that goes along with federal 404 permits. So now I'm going to jump into another section that Garrett and I have quite a bit of experience with, because this is mainly the section that we work in with DNR, is Section 303D. So Section 303D is essentially assessing or taking all the data that we have for all of the waters of Missouri and comparing them to our water quality standards. And then we'll list those waters as impaired if they don't meet those water quality standards. And then we can develop these pollution control plans or diet plans, essentially, for these water bodies to help them come back into water quality standards. So that's sort of this red circle area that you see here on this photo. And it kind of fits into the bigger picture in that we wouldn't be able to assess the waters if we didn't have water quality standards in the first place. So a lot of what we do really starts with those standards. It really starts with saying, what do we want to use the water body for? And if we want to use it for this, what are the specific criteria that have to be met in order for us to make sure that we can use the water body for what we want to use it for? And then, of course, monitoring comes into place. So, this could be lots of different programs, agencies. DNR does a lot of monitoring, but we use this data to then assess the waters. And then I'm going to get into, what we do after we go through our 303D process in further slides. Oh, I muted myself. Okay. Perfect. So to dive into a little bit more of what assessing water quality in Missouri looks like is essentially we have this data and we go through this big process of taking the data that we have and comparing it to those specific standards and criteria. And we do that by following something that's called our listing methodology document. This document literally outlines everything that we, like how we use the data and how we're going to assess that data to the standards. Excuse me. And then that listing methodology document gets updated along with our final list of the impaired waters. And that all goes through a public comment period and a hearing for the public. And so if you're wondering, I want to learn more about impaired waters in my area or just in the state in general, there's opportunities for the public to be involved with saying, I want to learn more about this, or hey, this data doesn't look right, or I know that there's more data on this water body than what you're seeing. And so we just want everyone to be aware that there's lots of opportunities for public engagement in these steps that we as DNR have to do according to the Clean Water Act. And then something that is specific to Missouri is this list of waters that do not meet our water quality standards have to go to our Clean Water Commission for approval. Most of the time, they approve the list, and there's not really much of an argument there, but it's another check that we have in Missouri for our water bodies specifically. And then every 2 years, so after the list goes to the Clean Water Commission, then we submit that to EPA fingers crossed by April 1st of even numbered years. And then EPA will sometimes partially approve, partially disapprove that list, and we kind of have to go back and forth on some of these water bodies until we come to an agreement. So during this process, we're also setting priorities for those watershed plans, or for those diet plans, or TMDLs, which I'll explain later, for the streams. And we say, you know, the water bodies that are impaired for specific designated uses might be more important to set priorities for than others. For example, anything that has to do with human health is probably automatically going to be bumped up in priority. We also identify the specific pollutants for each of those water bodies, and we try to identify the source of the pollutant. So if we say that a water body is impaired for pH, then we want to investigate and try to identify, well, what could be affecting the stream? You know, who's kind of to blame, so to speak, or who can we hold accountable for making that water body out of water quality criteria for pH, as an example. So when we assess the water bodies of Missouri, we go through it and we put them in all of these different categories. And I'm not going to go into tons of detail about all of them, but what I want to point out is that category 5 waters down at the bottom are on the 303D list itself. So whenever I talk about the list that we submit to EPA, if anyone's talking about the impaired waters list, that is the same thing as a water body being in category 5. It is on the 303D list. And what that means is the water body is impaired by a discrete pollutant, and no pollution control plan exists for that water body. So we as DNR are then charged with writing some kind of pollution control plan for that water body. Once that happens, then that water body goes into category 4. So that means that the water body is most likely impaired still, but it has some kind of plan in place to try to help that impairment come back into meeting water quality standards. So typically, category 5 waters are said to be impaired. However, category 4 and 5 waters are most likely still impaired waters. The other 3 categories are some kind of combination of we have enough data to say that some of the designated uses are being attained by this water body, or we don't have enough information to say whether or not this water body is meeting any of its designated uses. So that's categories 1 through 3. When we essentially list and post our 303D list on our website, what's also included with the 303D list are something called assessment worksheets. So you can go to this link that I think perfect Hannah just threw in the chat, and you can see our currently proposed list, 303D list for our 2026 303D submission to EPA. And in that PDF, you can pull up all of the data that we have used to assess those water bodies. And you can look at the specific samples, and you can read about what is the impairment, you know, what's the criteria that's not being met. And there's lots of really good information. So if you know of a stream that you might think is impaired near you, or you just want to learn more about any of the impairments in the state, then you can follow that link and know more about the data. So here's a map just for your reference. It's a little bit old. This is from the 2022 303D list. We have not quite updated our map viewer yet for the 2024-2026 impaired waters list. But just to give you kind of an idea of scale here, the water bodies that are highlighted red were on the 303D list in 2022, and the water bodies that are highlighted green were in category 4. So the red and green waters are most likely impaired. Well, the red are definitely impaired, and the green are most likely impaired waters of the state. Okay, so I've talked a little bit about those pollution control plans or those total maximum daily load plans. So I'm going to dive into that a little bit more here. So what is a TMDL? TMDL stands for total maximum daily load, and it's really just a calculation of how much this water body can hold in itself without exceeding water quality standards. So how much can this stream or this lake take without going over the top, and now we have to say it's impaired. Okay, so the TMDL can both refer to that specific calculation and it can refer to the whole document itself. These are typically very large documents because a lot of information goes into them. And so a TMDL can refer both to, this is the exact load of this specific pollutant that this stream can handle, and it can just refer to the document itself. So TMDLs take a lot into account, right? They answer questions like, why is a water body impaired? What are the potential contributing sources? And when is a pollutant loading likely to occur? So they take things into account like, what are the permitted facilities in a watershed? What are the non-permitted areas? So maybe high concentrated non-point source pollution areas. So this could be anything from agriculture land to highly populated areas, urban areas. And they also take like how much forested areas is in this watershed. They also, go down to the nitty gritty, like what are the soil types in this watershed? How well will water percolate down into the ground versus running off into the nearby stream that's impaired? And they also take things into account like, the wet season, the dry season, if the impairment is more likely to happen in the hot season or in more critical conditions for that water body, then they're going to take all those things into account whenever they're trying to figure out, what is the loading capacity? How much can this stream handle without going over the top and not meeting water quality criteria? And they do this with modeling. Essentially, a model is just a simulation of something that's happening in the real world. And a water quality model specifically is a mathematical representation of how a pollutant ends up, where it ends up in a watershed, how it's transported, and how much it degrades within a watershed or a water body. So the folks at DNR who do these are really smart and they work with models a lot, and they often have many, many equations that they put into these software that help them to understand how much a stream can handle before it will be too much for the stream. Okay, so that was a lot about TMDLs, and now we're going to switch over to briefly talk about reporting. So I don't know what all of you all do, but if any of you work for the government, you know that there's always a lot of paperwork that's involved with a lot of these things, and this is still true with the Clean Water Act. We are required, in addition to the 303D list and any TMDLs, we're required to submit to EPA a status of all of the water bodies. And we have to summarize our progress. And we have to combine all of this into something called the Integrated Water Quality Report, or IR for short. So it's a lot of information that we submit to EPA on a regular or cyclical basis every 2 years. And these are documents of varying degrees or varying sizes. I would highly encourage you all to read our 305B report. Actually, Stream Team is in there. We talk about what we do with Stream Team and the efforts that folks do with the Stream Team program, because it's part of our progress. It's part of what we're doing to help all of our waters of the state to maintain good water quality. The 305B report is a long document, but it's pretty easy to read, and it gives a lot of really good background on the geology of Missouri, history, and just where we're at as a state with our water bodies. So I talked about it. So let's just kind of briefly go over, well, what is the status, of Missouri streams? And just in short, this is sort of our draft numbers for our 2026 305B report. But for Missouri streams specifically, we actually only have enough data to assess about 10% of our water resources for streams specifically. And of that 10%, about 47% is impaired, and about 53% is either we don't know or is meeting some of their designated uses. And then for Missouri's lakes, we can assess about 84% of our lakes and reservoirs in Missouri, and about 83% of those lakes are impaired for various reasons. And neither of those pie charts are including the MDL streams and lakes as well. So the impairment percentage will probably go up just a little bit. So that was our reporting. So now, we've gone through all of this assessment and reporting, lots of documentation of what's going on. So how does the Clean Water Act, in addition to what Garrett mentioned earlier about helping to make sure that facilities themselves, so those point sources, are given the ability and the resources to help with upgrades and things like that, we also have a section specifically for non-point sources, so everything else, right? And this wasn't originally in the Clean Water Act of 1972 and was later added in the late 80s to help provide funds and grants to implement voluntary practices for those non-point source areas. So in the history of the non-point source program, from a federal perspective, the amount of money that's been given by the federal government to the states, to all the states, has varied throughout the years, which is what this graph shows. And for us specifically in Missouri, our total annual allocation has ranged from anywhere from $3.6 to $3.8 million. So it's a chunk of change to help with non-point source issues that we have in Missouri. So how does this happen? Essentially, entities will have to define what's going on in their watershed and come up with a plan that follows specific requirements. This plan will then have to be approved by EPA. Then those parties can receive funding for those 319 projects. These plans are voluntary, as I mentioned before, and the success of them really depends on folks in the community being led locally and involving lots of stakeholders, whether that's people in the community or experienced water resource professionals, people to help out and say, this is the problem and this is where we need to go to see these improvements for these non-point source areas. So to develop these plans, DNR on their webpage for the 319 program outlines these 9 key elements of a good plan. And what's really great is if a area has already had a TMDL written on it, so already had a diet plan written for a impaired water or water in the area, then it's already addressed the first 2 9 key elements of this plan. So it's already addressed what the causes of the pollution are and the load reductions that are needed. And so TMDL areas are really great candidates for these watershed-based plans. I'm not going to go into all of the other important aspects of the 9 key elements, but they're there for your reference. So what is how does this work? So essentially, the 319 program can grant a maximum of $400,000 for these funding projects, these 319 projects. And what's required is DNR would provide 60%, and then the entity would have to match 40% of that. So that's a lot, right? So typically, and actually only, non-individuals are eligible to apply. So what's listed there are entities that can apply for this type of funding. As I say that, though, if you are an individual and you're interested in helping out with a 319 project in your area, or you want to learn more how you can help, individuals are more than welcome to partner with any of these entities in drafting and writing and being involved with these projects. So here's some of the things that 319 projects can do. They can do things like setting up agriculture BMPs, or, installing rain gardens, or going from, a channelized stream to making it more meandering and more natural. It can be anything like riparian restoration. So what's the stream corridor look like? Any lake management practices going on as well. So there's lots of different activities and projects that can be funded under the 319 program. And it's really cool to see what people have done with 319 money to help restore streams and to help make sure that the non-point sources running off aren't getting into our water resources. So, just in case you were wondering, here's a map of our priorities through 2031 of 319 non-point source implementation areas. So everything that's highlighted on the map is a watershed that already has a 319 plan on it. And so if you're in any of these areas, or if you're interested to know more about the 319 projects that are happening around any of these areas, feel free to reach out to us and we can give you more information. There's also 5 plans that are currently under development. So this is also a really great opportunity for you to be involved as a stakeholder, as someone in the community. So if you're in any of these areas as well, I would highly recommend that you reach out to learn more about these plans and to see how you might be able to help or contribute, or have your voice heard, or just understand what's going on. All right, so last thing I'll mention here, and Garrett touched on it a little bit earlier, but what can you all do? And I've already talked a little bit about it with the watershed plans, but I wanted to make you all aware of signing up for our Gov Delivery program. So there's a link that you can use to sign up for any notifications that DNR sends out. And it's important because I think there's lots of opportunities for public engagement that people just don't know about. But every TMDL that we write goes on public notice, and you can read it, and you can submit comments to us, you can call us and ask questions. And as I mentioned before, our 303D list goes through a public comment period. Also, there's lots of permits that have their own public comment periods. So you all can be more involved than maybe what you might realize in what's going on with the Clean Water Act in our state. So Garrett already talked about public education, but I'll just mention with Stream Teams United, which I don't know if Hannah threw a link in the chat to their website, but here, I'll come back to that. But Stream Teams United is having a meeting 2 days from now on January 22nd. So I think that's Thursday, same time as this webinar, and you all can register for it using the link, and I think we'll throw it in chat. But I wanted to bring this to your all's attention because, making your voice heard to your state and local governments really can't be understated. And so Missouri Stream Teams United is really our avenue for advocacy for our stream resources. So if you want to learn more, this will be a great opportunity to ask questions and to understand more about how you can make your voice heard and advocate for our water resources. And then I'll just go back here and mention with our volunteer water quality monitoring program is we have lots of folks, which I think many of you are involved with, but this map shows where anyone who's been a part of the VWCM program has monitored in the state. And as you can see, it's a lot. And I cannot understate how amazing our volunteers are, that they go out and they care and they collect data to see what is going on in our streams. And this data can be used for a plethora of purposes. That are listed there on the side and more. But this is a huge way that people can understand more about our water resources. So I highly encourage you all to get more involved with the Volunteer Water Quality Monitoring Program. You'll learn probably way more about water quality than you ever thought you wanted. But it's really great to just understand, how do watersheds work and what does good water quality mean? And whenever you put your meter in the water and you submit your data sheet, we look at that and we're using that data to understand more about our water resources. And you can use that data to tell people this is what's going on, in the stream in my backyard or at my favorite park or, down the road. So with that, I will put mine and Garrett's contact information up on the screen here, and then we also have our DNR general stream team inbox as well. So if you have any questions, we can take them now. If you want to just put them in the chat, we'll answer them. But I think we have a few minutes left for questions. So I'll leave my screen up to share the contact information, and I'll pull up the chat here. And I think maybe Hannah, you are maybe going to help us kind of facilitate answering questions as well.
Yeah, so far, there's no questions in the chat. So
Okay.
you did such a good job explaining everything. I
Okay,
did put
perfect.
all your links in. I just want to mention that the Stream Team United Advocacy meeting is only for
Yes.
Stream Team volunteers. So if you are currently a Master Naturalist volunteer and not a Stream Team volunteer, now's the time to get involved.
Yes, that was explicitly stated that the Stream Team United Advocacy meeting is for Stream Team members only. And I will say, as Garrett mentioned, we are not Clean Water Act experts. However, we work with lots of people who do a lot of things regarding permits and the Clean Water Act. And so if you have a question that we can't answer, we will surely be able to find the answer for you and get back to you. So don't be afraid to ask any questions. Donna, which link will get me to the current Quiver River work? There's no specific link to that, but Donna, we will get your contact information, and I don't know if we can ask, maybe Donna can send her contact information in the as like a private chat. Or maybe
Donna,
we
if you
have.
would like, you can just respond to Pam Taylor sent out the link for the webinar. You can just respond to that email and we can get you the information.
Yeah, or you can email Garrett or I on the screen, and I can get you more information about the Quiver River.
Steve also had a question. Do TMDLs address combinational effects of multiple contaminants in a stream?
That's a good question. Typically, oh, go ahead. I don't
No,
know.
I'm sorry.
Garrett.
You're going for it.
Well, I was just going to say, typically, I think TMDLs address a discrete pollutant. However, if the combination of pollutants affect, if one affects the other, then I would imagine, yes, that they would address how that pollutant works in the system, if that makes sense. Maybe Garrett, you can explain it
Nope.
as
That was fine.
well. Okay. So
TMDLs are complicated. There are a lot of moving pieces,
yes,
but yeah, I think you got the gist of it right there, Tab.
right. So like if a water body is impaired for pH and temperature, those those two are related to each other. So because they're going to affect each other, um, in order to address one pollutant, you have to kind of address the other. However, most, the total maximum daily load has to be for one type of pollutant. So where the document itself is going to probably include um, how those multiple pollutants might affect each other, the the TMDL itself will only address one of them. There can be multiple TMDLs on the same stream, though, and there are multiple TMDLs on the same stream for different pollutants. So, if that helps.
Okay, and then Gail would like to know how to find out what work/data is available to see on creeks in the Jacks Fork watershed.
Yes. Are you looking for stream team specific data, or are you looking for agency collected data that we would use for like our water quality assessments, or just all the above? If you put that in the chat and then send us an email, we can get you either or both.
Um, do TMDLs address physical degradation in a stream, such as substrate issues?
I think if it pertains to the impairment, yes.
Yeah,
Garrett, would you have anything to add to that?
I'm not sure. I can't think of a single TMDL I've seen that is written for a more physical impairment like that, or physical matter, rather. Um, we do have some scattered cases where a water, typically a stream, I think, is impaired um, for kind of a not unknown, but like a difficult to pin down sort of reason. And some of those cases we call them just generic habitat modifications. So we know something's wrong, but it's kind of just the entire habitat has been affected to create this really big tangled mess of um, not impairments, but degrading factors. And so we typically, I think, try to address those sorts of scenarios in not TMDL sorts of ways. They are addressed in kind of related ways, but a TMDL has a much more sort of formal structure to it that I'm not sure we do apply for this sort of thing. But we do see these, we do have methods for them. When I first joined DNR, worked on a bunch of statistics and wrote up a report on a sediment issue in a stream that was used to try to say, we have this problem and this is how bad it is, and let's do something about it. But TMDLs just might not be the right tool for that job, I guess.
But I can also ask TMDL folks this specific question
Yes, and we're gonna
for clarification.
after the webinar, we're gonna summarize all of the Q&A session, and I can have Garrett and Tabitha add on any extra thoughts they have to the answers to these questions later on. Are there any streams in Missouri that have been removed from the list after successful remediation?
So any stream that has a pollution plan in place or a TMDL in place is removed from the list and is then put into that category 4. However, there are very few, and I can't think of any off the top of my head, maybe Garrett can, that are now meeting water quality standards from after being removed off the list from category 4. That was a jumbled way of saying it. But there are water bodies that kind of go on and off the list. They kind of oscillate between being impaired and then coming back into water quality standards and then being impaired again. But that's more because of the nature of the impairment and less about, there's something that's changed in the watershed that has really addressed the impairment itself. So I'm not aware of any, but I do know that there's obviously lots of remediation efforts happening, but ones that are that targeted, I'm just not aware of. But I can also double check that.
Okay, and do trees planted near bodies of water tend to increase the level of dissolved oxygen in the water?
So trees being planted near bodies of water can impact dissolved oxygen in the way of water temperature. So if there's more shade over a water body, the cooler the water can stay, and colder water can hold dissolved oxygen better in the system. So it can kind of indirectly help with dissolved oxygen in a stream. In addition, that's probably the main way. Trees can also help absorb maybe excess nutrients that could be running off of the watershed, or not just trees, but any plants that are planted along or growing along a water body can help absorb nutrients that may or may not be running off into the water. And nutrients can affect plant growth or algal growth inside of a water body. And so if there's lots of excess algal growth, then that can definitely negatively impact the amount of dissolved oxygen in a stream. So in that way, the uptake of excess nutrients can help keep algal growth down in a stream, which will in turn help the dissolved oxygen in a water body stay within the normal fluctuations that we would see. I hope that answers your question. And Garrett, if you have anything to add to this, feel free.
Oh, sounded good.
Okay, is stream bank erosion considered impairment? To us, it is severe impairment with many streams, creeks after floods of last year.
Garrett, do you want to take this one?
Sure. So no, the erosion itself is not considered an impairment. That's not to say we don't treat it as an issue, and we might want to have the appropriate part of DNR or other agencies step in and try to help out with that erosion. The erosion, however, might cause, say, a bunch of excess nutrients if it's an agricultural field that's eroding into it, or further down south, maybe there's extra heavy metals that are eroding. The erosion might be contributing to something that does actually impair the stream. But typically that erosion itself wouldn't be considered an impairment. I hope that clarifies. There's a very specific sort of way an impairment has to be considered and addressed. And a lot of things might cause impairments, but not be impairments themselves, which can be a little bit of a tricky thing to disentangle sometimes. But
I have a question related to that.
yeah,
For erosion, does that lead to more total suspended solids, and would that be an impairment?
It almost surely would lead to that increase in TSS. We don't have a water quality criterion for total suspended solids, however. So you
Okay.
can't impair something based on a non-existent criterion, which is kind of that complicating factor. There could be ways to still, through our framework, address that erosion and increase TSS. That could be potentially, I'm not perfect on the details of how this all works, but that could possibly fall under our narrative criteria, those generic qualitative descriptors of, well, further upstream, the stream looks healthy and good. And as soon as you start getting toward where the stream bank is and further downstream, the stream looks muddy and it's full of all this really fine sediments. And that's just not how it's supposed to look. We might be able to do something through that. And we just do have other methods that we can apply toward trying to address issues like sedimentation as a result of erosion or other means. But yeah, to answer your specific question, TSS doesn't have a criterion, so we can't actually impair based on that.
Okay.
I will add to that as well. Sediment in general is a huge carrier of pollutants that we can address that do have criterion. So, like bacteria or pesticides, those to just to name a couple. So, erosion and therefore excess sediment and therefore excess pollutants really is honestly, it's the driver of many of our pollutants that we do address with our water quality standards or water quality criterion. So even though the erosion per se or the sediment itself isn't necessarily addressed in the criteria, many things that are that come along with that are addressed.
Okay. Thank you. I think we're gonna start wrapping up here. So thank you to all of our attendees for staying with us through our technical difficulties, but we made it here. I will be sending out a follow-up email that will have the recording, the slides, the links, and then a summary of the Q&A session. So hopefully that will be going out by the end of this week, so you guys should see that. And I see another question just came in. I can add that to the list and get that in that follow-up document. So if anybody else has any questions, feel free to add them or send us, any of us, an email about it. And then I just want to say thank you to Garrett and Tabitha for presenting tonight. You guys gave us a lot of good information.
Happy to be here. We really appreciate all of our stream team volunteers and all the volunteers who work with Missouri Master Naturalists. And really, it's a privilege to have this opportunity to get to talk to all of you. And yeah, hopefully we'll see you guys sometime around.
Yep, it means a lot that you guys care enough about this to participate in the programs and show up to a webinar like this. So appreciate it.
All right, thanks again, everyone, and have a good night.